This question is from the 2015 higher level DCG paper. It's section C, applied graphics, and it's the geologic geometry question, question C1. The accompanying map located on the back page of section A shows ground contours at 5 metre vertical intervals from an area of hilly countryside, similar to that shown below. ABC is the centre line of the proposed roadway and DEFG is a proposed car park. The roadway ABC has the following specifications. Section between A and B is level at an altitude of 65 metres. So A and B are both at 65. The section from B to C is rising uniformly to a level of 70 metres at C. So C there is at 70. And the sides DE and GF of the car park are levels. That's those two sides there. Using the side slopes of 1 in 1 for cutting and 1 in 1.5 for embankment, complete the earthworks necessary to accommodate both the roadway between A and B and the car park on the northern and eastern sides. The earthworks on the southern side have already been completed. Okay, so we'll do the bit between A and B to begin with. 65. We have to first figure out, are we cutting or filling here on top? So all the contours, well, there's a change of contours, so we'll start over here on the right hand side at A. Contours are below 65, so 65 there is the changeover point. So on this side they're below 65, so that means we're going to be filling and or embankment, 1 in 1.5 for embankment. So to figure out the distance between them, you go to the difference between the contours here, so there's 5 metres multiplied by 1.5 because that's your slope for embankment, which gives us 7.5. So we measure up in 7.5s here for the intervals. Okay, the one at the road has to be 65, so that'll be 60, 55 and 50. So that one's 65, that one's 60, 55, 50 and 50. Okay, that gives us the first section there. Next one now we're going to be cutting. Cutting is 1 in 1. So the vertical altitude difference between the contours is 5. So 5 multiplied by 1 is 5. So there's 5 millimeters between the lines over here. 2 should be enough there. Again, the road starts at 65. Next one up would be 70 and 75. So that one's 70, 75, 75 and 70. Okay, that gives us a slope there. Now they told us G to F was level, so same thing again. We're going to be, it's level at 65. We're going to be, are we cutting or filling? 65 hits there, so 60, 55. We're going to be filling here for this. The difference between the lines was 7.5, so it's going to be 7.5 again from these. Again, starts at 65 and we're filling, so it's going down, so 60, 55 and 50. 65 was there, that's 60, 55, 50, 50 and 55. So it starts to go back in on itself there. So I'll just do heavy for this one because I'm not sure yet where it crosses over with this. I'll do that one there as light. I'll continue up actually to that. 60 is up there at the top as well, so I'll just do that as light. Not sure where it starts heavy there. Now, on the top here, EF is sloping here. So they tell us that E is at an altitude of 70 and F is at an altitude of 65 here. So first thing we need to figure out, are we cutting or filling? So in this case, let me see, 70 is there, 65, 60, 55. So we're going to be filling here on the top. Then the rule is cut at the foot, fill at the hill for where to position your cone. So we're filling, so fill at the hill, the highest point is E. So our cone is going to be at E, or semicircle. And what size does it need to be? Well, the difference in altitude from B to C is 5. So it's 5 multiplied by embankment, which is 1.5. So it's 7.5. Radius 7.5. Then the line runs from F as a tangent to that circle. That's the first line, and that one there must be at 65 because it touches F there. Distance between the lines, then again we're filling, so it has to be 7.5. And then each line will be parallel to that tangent line. Starts at 65, 60, 55, 50. Now, 60 touches at that point, 65 at that one, 70 would be the one at the very bottom if I did another line there, so it joins back to E. 65, 55 is that one, 50, where does that go to? Way back up to there then. Okay, so that's my crossover point now. That would be a heavy line the whole way to there, and then it crosses over and goes to there, so that little bit there will be heavy too. Now you could draw a line there back to F just to show that that's the corner. Okay, that's part A of the question finished. Part B now. On the map, vertical boreholes at points P, Q and R reveal the top surface of a stratum of ore at altitudes of 30, 35 and 45 meters respectively. Careful there, it says altitude, so that's your distance up from ground level. In the space provided at the top of the map, draw the elevation of this triangular portion of the top surface of the stratum and determine its strike and dip. Okay, first thing we can do, what was the top one there? It goes up to 45 is the highest one. So the starters there at 20. I'm going to go up in 5mm intervals. That one's 20, 25, 30, 35, 40 and 45. Now they tell us that P, Q and R, so P is up 30. That's P. Q is up 35. Q and R is an altitude of 45. Okay, we can draw in the triangle then of the surface in front elevation. And then to get the strike and dip, strike is always the same method, a horizontal line on the surface of the triangle. So in this case it's easiest to go from the middle point, that's Q, with a horizontal line the whole way across. So that goes across to that point on the line RP. I can drop that down to the line RP in plan, which gives me that point, and if you join it back to Q, then that gives us the strike line. So label it as strike for the examiner. Once you have the strike, then to get the dip, you take an auxiliary view along the strike. So x1, y1 perpendicular to the strike line. That's x1 and y1. Bring up your 3 points at the same angle as the strike. And get your altitudes from front elevation. So we know the altitudes. R is 45. P is 30. And Q is 35. And if you draw the angle, should give you a straight line because you're looking at an edge view. That angle there, now if you extend it the whole way down, that angle between the two is called your dip. Dip angle there. And that's question part B finished. Part C now, a lake is located in the area marked L on the southeast corner of the map. The surface of the lake is at an altitude of 50 meters. So I'm just going to write 50 there on that. The line ST represents the center line of an overflow pipe from the lake. The pipe travels from the point S at an altitude of 50 meters to a manhole located at the point T. Okay, so S is at 50 meters there, and it travels along to the manhole at T. The pipe falls uniformly at an angle of 10 degrees. Determine and indicate in meters the depth of the pipe vertically below the ground at point T. Okay, straightforward there. We're going to take an auxiliary view looking in perpendicular to ST. So it's kind of like your section profiles that you have in other questions. So draw an X1, Y1 line up there. X1 and Y1. And then you're going to bring up your 2 points perpendicular, so line up your set squares in line with it. Bring up point T and point S. And we're told S is up in an altitude of 50, which brings me to there. So that there is point S at the full altitude of the lake. And then we know that point T is on the 40 contour. So I'm going to measure up 40. So the manhole lid is at that point there at T. And they wanted to fall at 10 degrees now. So you need to use your protractor and measure 10 degrees. So I'm going to go from the ground. Doesn't really matter what way you do this. Mark 10 degrees there. So that now is the angle of 10 degrees. If I use that then with my sliding set squares, mark that from S, because that's the height of the lake, down to there. That's where the pipe ends up below ground level at T there, if it's travelling at 10 degrees from S. Okay, so they ask us in the question, determine and indicate in meters the depth of the pipe vertically below the ground. So in this case, it works out at 0.8, which is scale 1 is to 1,000. So that's 0.8 meters. Actually, if we scale that up, 0.8 meters would be too small because each millimeter represents a meter, so it would be 8 meters instead of 0.8. Okay, so it's 8 meters below ground level there. And that would be your question finished.